Hi, I'm Carl Franklin. In this episode of the .NET Show, I'm going to share a fun little project of mine that turned into a library that you can use to automate UI in the browser. By automate UI, I'm talking about watching a portion of the screen for specific text or searching for a given PNG graphic at a certain area of the screen, and then acting on it, either by clicking at a certain coordinate or sending text, simulating key presses. Now, I know there are plenty of tools to do this kind of thing. Some are free and some you can buy, but that's not the point. The point is that it's a fun project that you can use at home to do some really cool things. In my case, I'm going to ensure that a webcam site stays running, as it times out after a while and requires you to click to keep it going. Now, just because you can use this to manipulate websites doesn't mean that it's always okay to do so. You should definitely check your license agreement or user agreement to ensure you're not breaking the law. Automating browser UI is coming right up on the .NET Show. So as you can see, I'm starting at my GitHub repo, which is public, called Screen Tools Demo. And this has everything that you need to recreate and understand the demo and the library. We're using a .NET Framework C# class of utilities, it's actually a library, to automate screen interactions. The demo looks for the word "still watching" on a streaming webcam website in a full-screen browser, and then clicks on the screen when necessary to keep the webcam going. It also looks to see if the site is frozen and presses F5 to restart it. Also, if the webcam page goes out of full screen mode, it clicks the full screen button. To use the Screen Tools library in a .NET Framework console app, you have to do a couple of things. You need to add a NuGet package for Newtonsoft JSON, and you need to add references to system configuration, system drawing, and system Windows forms. Let's do that now. So I'm going to create a new console app, but it's a .NET Framework console app, not a .NET Core console app. And I'm going to call it Screen Tools Demo. So the first thing let's do is manage the NuGet packages, and we'll go find Newtonsoft JSON and install it. Now, we also need those assembly references because I don't know if you've ever done this in a .NET Framework app. You have to add reference and then go into assemblies if you want to use different parts of the .NET Framework that aren't included in the project by default. So I'm going to scroll down to System Configuration, check that off, and then System Drawing, and finally System Windows Forms. Now, why do we need System Windows Forms? Well, that's where Send Keys is. Send Keys is a very nice tool that lets you send keystrokes to the current window, the one that has focus. Now we need to add that project Screen Tools Lib. It's in the repo right here. So you could download the code, you could clone the repo, whatever. I'm going to right-click on my solution and add an existing project. You can't see it because it's off screen, but I'm adding an existing project, and that's my Screen Tools Lib right there. So herein is everything you need completely encapsulated to do this UI automation. Now for the demo, I'm going to add a project reference. So I'll select Add and then Reference, and then go to Projects, then Screen Tools Lib. There it is. Now I'm just going to build it to make sure everything works. And it does. So before I even write this code, let's take a look at Screen Tools Lib and all the classes inside it, starting with UI Action. So this enumeration defines an action that you can perform. Currently, you can click on a given screen coordinate, and you can also send keys, simulating keyboard input. So text area is the real meat of the project. Let's look at the properties. Text defines the text on the screen to look for. Compare PNG path. If you're comparing the bounds here to a known PNG file, it defines the path to that PNG file. So you can look for the occurrence of a bitmap within the screen. That's pretty cool. Bounds defines the rectangle, or the screen coordinates, on the screen where the text or image will be. Only check if frozen. If it's true, it only does a check if the screen hasn't changed since the last capture. See, what happens is we go through this period of waiting. There's like a waiting period or a pause. And after that pause, let's say it's 5 seconds, the library goes through all of these text areas and does each check and applies them. And so if the text matches, then it will either send keys or click, but you can also specify that you only want it to check if the last time we went through the loop, the screen hasn't changed, indicating that it's frozen. Okay, so now here's our UI action. Remember, that's click or send keys. Contrast adjustment is an integer, and this allows you to increase or decrease the contrast of a bitmap before comparing text. And what you typically do is you go into the bounds, right? And you say, in this part of the screen, I'm looking for this text. But sometimes the contrast needs to be adjusted before the OCR library can read the text. So a negative number decreases the contrast, and a positive number increases the contrast, and you can just play with it. Rotation degrees, when it's not 0, specifies a number of degrees to rotate the bounds before comparing text. Now here's the deal. There's really only 3 options: 90, 180, and 270. I'll fix that at a later time. So next you have keys to send. So if this is not an empty string, when it matches the text at the bounds, or you're looking for a PNG, right? If you're checking a graphic, it will send those keys to the browser window. Now the click coordinates, if you're not sending keys, but instead you're going to click, this is the point on the screen where it should click. Hover is a cool feature. When this is true, then before clicking, it'll wait this many milliseconds, hover milliseconds, and then move the mouse over 1 pixel. Sometimes you need to hover over an area to pull up some UI, like a toolbar or something like that. In the demo, that's exactly what we use it for. All right, now let's look at Site. Site defines a website to load in a Microsoft Edge browser. So this is one level up from text area, right? So the name and the description properties are there just for your documentation. They're not used by the Screen Tools Lab. The window title is a partial or complete case-insensitive title used to identify the browser process. So when you load the website in Edge, you want to look at the window title, and then you can set this property to all or a part of it, and it's case-insensitive. This is how Screen Tools Live is going to find the window. The URL is obviously the URL of the site, and then text areas is a list of these things, which are the actions that we want to happen when. So this is the when, where, and how, the meat of this library. All right, now let's go to settings, and this is the top level. So settings defines a screen index, right? So this is the 0-based index of all the screens enumerated in Windows. So I have 2 monitors. This one right here is actually a big 49-inch monitor. It's big. And I'm just recording a little piece of it in Camtasia. The interval in seconds is that interval in between checks for all of the text areas in the site. Now, the list of sites, I really am only using one. I don't have code in there yet, as of this recording, to handle multiple sites with multiple monitors, but if I did, that's how it would work. So when you're using Screen Tools Live from an application such as this, you want to do two things. You want to define a settings object, and then you want to call screentools.automate, passing in the settings. And that's it. That's all you have to do. Now, I'm going to show you a demo right here. I'm just going to replace all this with what's in the repo. And this is a demo that looks for a settings JSON file in the current directory. If it's there, it will be loaded and deserialized. Otherwise, the demo code will create the settings object, serialize it, and save it to settings JSON. Okay, so before we get started here, there's one more file that I need to copy into Screen Tools Demo, and that's this right here, white.png. And so this is used to detect when the website is not in full screen mode. So I'm just going to copy that from the repo. There it is right there. And I'll make sure I copy that if it's newer. Okay. So now I just want to reiterate that this demo does not condone manipulating websites with actions that may be prohibited by the website's license and/or usage agreement. So this demo is for demonstration purposes only, so use it legally. So here's what we're doing. We have this settings object. We're looking to see if the file exists, and if you want to uncomment this line to write the settings file every time, you can do that. But if the file doesn't exist, then we're going to create a settings file with the demo data. So we're asking the user to pick a screen for the webcam site. Please select a screen. Typo. Please select a screen where the webcam browser will be shown. So I enumerate all the screens. I write out the index, the width and the height. Then I read a key, convert that to a key character, -48 to get 0, 1, or 2, or 3, or whatever. And make sure that it's valid. Go around again if it's not. Otherwise, I'm going to get the screen index, going to get the screen, create a new settings, set the screen index there, and create a new site. And then this is all the data for that webcam, right? The window title, description, the name, the URL. Now I'm going to create the text areas for the site. So the first one is a rectangle for still watching, right? It actually puts that right in the middle of the screen. Here, let me show you. See, there it is right there. Okay, so the action we want to take if we recognize this is click. And here's the point at which we want to click, which is right in the middle of the screen, doesn't really matter. And that's all we need to do to define that action. So we're going to add that to site text areas. Now let's go back and look at that picture. Another one of the rectangles that I can use is 9. It says 9 in the upper left-hand corner, but it's rotated. So first I create the rectangle, and this is a vertical rectangle because it's rotated, right? And then I tell it to rotate 90 degrees and send an F5 key if it finds that. The next one is the same rectangle, the same 9, but I'm adjusting the contrast in case this one doesn't work. Now I'm reducing the contrast to try that and see if that works. Now there's another one here. If you look in the bottom left, you'll see Dublin Cam. I'm only checking if it's frozen. All right. So if the webcam freezes, then I'm going to press F5 to restart it. Now I'm looking for white. Take a look at this. This is where I'm looking for that white patch. And that means that this thing is not in full screen mode. So what I need to do is hover down here, allow the toolbar to come up, and then right around here, you're going to see a full screen icon and click on that. So here's my compare PNG path, my bounds. The action is click. I'm going to set hover to true and hover for a second to show the control bar. And then I'm going to click on this particular point. Now this text, it's another test. If I see welcome to Dublin, Ireland, which is right down here, then I'm also going to hover and click to go full screen. And then I add the site to the settings. Remember, the sites is really only set up to do one site. And then I'm going to save the file. Now, if the file is there, I'm going to load it and deserialize it into settings. And then either way, I'm going to run the automation passing settings. So before we do anything, let's run it so we can see what that JSON file looks like. So first it's asking me to select a screen. It's going to be 1. And now it's monitoring. I'm going to close it. And if I look in Screen Tools Demo, in bin, debug, I see settings JSON. I'm just going to load that into my project and select copy if newer, format, and then here you go. So you can use whatever method you want to create this JSON file. This is what Screen Tools Live actually uses to do its dirty work. Okay. So now let's look inside Screen Tools. These, of course, are the imports for the Windows API that we're going to need. And let's look at Automate. The first thing we do is find the browser. And if we can't find the browser, we're going to load it. So let's go to this, load or find browser. So I get the current window handle, foreground window, whatever that is. It's whatever window you're using at the moment. Mine's Visual Studio right now. And then I get the site. And now I call another one, find process by window title. And I broke it out because we're calling it twice here. Let's go there. This returns a running process or null given a partial window title. So we get a list of processes that are running, and we go through each one. And I look at the process main window title, and if it's not null or empty, I do a case insensitive partial search. Process main window title to lower, contains title to lower trim. If I found it, I return it. Otherwise, I'm returning null. All right, let's go back. So if I can't find the process, I'm going to start it. Here's a new process. I'm going to start it maximized, Microsoft Edge, and I'm going to wait 300 milliseconds. It's a good idea to do this. And then I'm going to look again. And if it's not null now, then I'm going to get the screen reference. I'm going to move the window. This is an API call with the main window handle to XY width, height, and true. True is repaint. Then I'm going to set that as the foreground window because I'm going to send text to it. F11. That's how you do that. With a little sleepy sleep on either side, current window handle. I'm going to set that. So we go back to where we were, and I'm going to return this process. Now, whatever this process is at this point, even if it's null, we're going to return it. All right. Let's go back to Automate. So by now we should have this process, and I'm not checking for null here because Edge is pretty much a known application it's going to run, unless you've removed it somehow. So this last screenshot holds the last shot that we took in between those intervals. And so I'm keeping that around because I need to compare it. So now I get a reference to the screen. I pull out the first and only site. I say we started monitoring, and now I'm automating. So I'm going through a loop while a key has not been pressed. So now I'm pausing 1 second for every interval in seconds that's specified in settings. I'm going to create a bitmap, the size of the entire screen, screen bounds width and height. I'm going to create a new graphics object from that bitmap. And then I'm going to take the screenshot, the entire screen, graphics copy from screen. And now I'm going to go through my text areas, right? Now remember, this is in a loop, pausing for a certain number of seconds. So within this loop, here's the loop going through the text areas. So if I'm only checking if frozen, and the last screenshot is null, just ignore it and move on to the next text area. But now I'm going to check to see if the bitmaps are equal, the last screenshot and this bitmap. And if they're not equal, I'm going to move on. If they are equal, I'm going to continue processing the text area. So here's the crop, bounds, right? We crop it. Check to see if it's rotatable. And this is where I'm just sort of chinsing it. I should probably set, instead of rotation degrees, set it to a rotate flip type, but I don't want to support flipping and all that stuff yet. I guess I could. Doesn't really matter. But anyway, there's the rotating. If I'm adjusting the contrast, I call an adjust contrast method. We'll go through all these. So I'm comparing a PNG. I load that bitmap, and then I check to see if the bitmaps are equal. And then I call process UI action, which is the main thing that either does a click or a send keys, and we'll get to that. Otherwise, we're going to get the text, right? Because this is checking the PNG path. Otherwise, we're going to check the text. So get text reads uses Tesseract, which is an open source library to read the text in that bitmap. And if it matches, I'm going to call process UI action. And then I'm out of the loop and I'm getting the last screenshot, and that's it. All right, so let's look at some of these methods here. Bitmaps are equal. This is a little utility that I wrote to compare bitmaps. Now, you want to make sure that you're using the smallest bitmap as possible because, yes, it's locking the bits and it's walking through them in memory, right? So if you're comparing the screen, it's going to take some time, right? So that was bitmaps are equal. Now let's look at crop bitmap. It's very simple. We're doing a clone, passing in a rectangle, and returning that copy. Simple. All right, let's look at rotate bitmap. We're passing in the cropped bitmap and passing the rotation type for 90, 180, or 270 degrees. Let's look at that. Again, pretty simple. We clone the bitmap, and then we call rotate or flip with this rotate flip type enumeration and return it. All right, next, adjust contrast. This one's pretty cool. This is using the set color matrix of an image attribute and creating a new image with those attributes. Okay, process UI action. Let's look at that. So this processes either a click with the hover feature or a send keys action. So we get the foreground window, and if the action is send keys, we're switching to the browser window, we're waiting 300 milliseconds, and then we're calling send keys. Then we're setting the foreground window back to our window. Now, if it's click, we create a new point. We call it get cursor position. So that gets the position of our cursor because we want to move the cursor back where it was afterwards. And then we change to the cursor position in click coordinates, X and Y. Now, if we're hovering, we're going to move the mouse by 1 pixel and then wait. And I say 1 second here, but really we're waiting however many hover milliseconds. And then we're calling click. Click is another method I'll show you in a minute. At X and Y, we're setting the cursor position back to where we found it and the foreground window. All right, let's look at click. By the way, these are all public methods, so you can call these outside of the library too. So this clicks the mouse at a given coordinate. So we have a point, we call get cursor position. We set the cursor position to X and Y. We call mouse event, left down, left up at X and Y. And then we reset the mouse position to where we were. Okay, then we have get text. getText uses the Tesseract library to read text in a bitmap. Tesseract is one of the libraries that I have in Screen Tools Lib. There it is right there. So we're not comparing it here. We're just reading the text out of this bitmap. Now this bitmap is going to be cropped already, right? So I've found that using Tesseract with a temporary file is the best way to read it. So I basically create a new temp file and save it. And now I'm creating a new Tesseract engine, and it's using this test data English training data. And that's over here in test data. This ing.trained data is the English language training. Now I've added a link to the repo where all of the other languages training data is, and you can just copy them over if you want. So Tesseract has a pix, which is an image, and you load it from the temp file. And then I'm calling engine process on that image and creating a page from that. And from that, you can get the text with page.getText.trim. Delete the temp file, return the text. Now this is a function that I'm not using in the demo, but you could use that if there's text that's going to appear on the screen, but you don't know exactly where it is. So this returns an area of a given size of a bitmap that has the highest contrast. So basically you can pass the screen, you want to pass it the size that the text fits in, and then the highest standard deviation allowed. And so that's what this does. It uses this compute standard deviation, which is a lot of stuff that I don't really understand, but because I was falling asleep in statistics class in college. Well, anyway, so if you know what this is, then you know it. If not, just know that it works. All right, let's run it, shall we? I'm starting it. It opens up the URL, presses F11, and now all of a sudden it's going to click on that full screen thing, and here it's going to sit until it pauses. All right, so there we go. It's paused, and now we're going to wait a second, and we click. Hey, that's my demo. Thanks for watching. I'll see you next time.
Thanks for watching. Please visit blazertrain.com and the .NETshow.com for more great content.